Hello everybody, this is Mr. Dooley, and I'm going to be taking you through today's lesson. Today's lesson is building on finding the roots of polynomials, and in this lesson we are going to be looking at problems where your lead coefficient is something other than 1. So basically what we would say is a is not equal to 1. And you could see in this first example, this polynomial here, you could see that our leading coefficient here is 6. And so this is a perfect example to get us warmed up on. The other reason why this is a really nice example is because this problem is this polynomial is a quadratic. And it's really an Algebra 1 question. You know, how do you, it says determine the roots of the quadratic function by factoring. Okay, well, we learned how to factor that in Algebra 1. And so I would use split the middle term. So I would be looking at factors of negative 30 that would add up to 13, and that would be 15 and negative 2. And so we split this middle term up. And factor out a 2x, get out of there. Factor out a 5. And here's our factors, 2x plus 5 times 3x minus 1. And if we are going to find the roots, we would set that equal to 0, set each of those factors equal to 0, and we would have our roots would be negative 5 over 2, and x would be 1/3. I want you to take a really good look at these roots. Both of them are fractions, and the numerator of both of these fractions here are factors of the constant. They're factors of 5, negative 5. And the denominators, 2 and 3, these happen to be factors of the leading coefficient. And so that kind of fits into what we've been talking about with the rational root theorem, that I'm going to just erase this so you don't get all muddled up, is that when we do the rational root theorem, it says that we would get factors from the constant and divide it by the factors of the leading coefficient. And so our answers here match exactly with what we would expect from the rational root theorem.